Good morning, my dear Senior 3 students. Our lesson today in calculus is higher derivative of functions. You know that if y equal f of x, then y dash, which means dy by dx, equal f dash x. Y double dash is d2y by dx squared, or f double dash of x, or d by dx to dy by dx. Yn, which is mean dny by dxn, equal fnx, where n is a positive integer number. Let's take some remarks. Number 1, d2y by dx squared, we read it as d2y by dx2. Number 2, the derivatives of a function starting by the second derivative is called higher derivatives, and the derivative of order n is written as the following: yn equal dny by dx power n, or fn of x, where n is a positive integer. Number 3, note the difference between d2y by dx squared and the first derivative dy by dx all power 2. The first one is the second derivative, and the second one is the square of the first derivative. dy by dx times dx by dy equals 1, but d2y by dx squared times d2x by dy squared doesn't equal 1. dy by dz times dz by dx equals dy by dx, but d2y by dz squared times d2z by dx squared doesn't equal d2y by dx squared. There is no chain rule of the second derivative. The chain rule is only valid for the first derivative. d by dx for y dy by dx equals first times derivative of the second plus second times derivative of first, which is mean bring down y, and the derivative of dy by dx equal d2y by dx squared plus bring down dy by dx, and derivative of y is dy by dx, which is mean dy by dx all power 2. Example number 1. If y equals 1 over 4x power 4 plus 2x power 3 minus x power 2 plus 3x plus 1, find d2y by dx squared at x equal 2. dy by dx equals 4 times 1 over 4 would be 1x power 3 plus 6x squared minus 2x plus 3. d2y by dx squared, 3x power 2, 12x minus 2. And replacing x and writing instead of it 2, it will be 34. Exercise number 2. Find the third and the fourth derivative for each of the following. Number 1, y equal x power 3 minus sine 2x. So dy by dx equal 3x power 2 minus 2 cosine 2x. d2y by dx squared equals 6x plus 4 sine 2x, because the derivative of cosine is negative sine. d3y by dx3 equals 6 plus 8 cosine 2x. d4y by dx4 equals negative 16 sine 2x. Number 2, y equal x over x minus 1. The first derivative dy by dx equal squared of the denominator. Derivative of first equals 1 times second x minus y minus derivative of second 1 times first is x. Cancelling x and negative x, so it will be negative 1 over x minus 1 power 2, which is mean negative x minus 1 all power negative 2. d2y by dx squared, bring down negative 2, it will be here positive 2, x minus 1 power negative 3. d3y by dx3, negative 6, x minus 1 power negative 4, which is mean negative 6 over x minus 1 to the power 4. This is the third derivative. The fourth derivative will be positive 24, x minus 1 power negative 5, which is mean 24 over x minus 1 to the power 5. Example number 3. If y squared equal x squared times 4 minus x, prove that y d2y by dx squared plus dy by dx all power 2 plus 3x equal 4. Since y squared equal, distributing x squared here, it will be 4x squared minus x power 3. By differentiating with respect to x, it will be 2y dy by dx equal 8x minus 3x power 2. Dividing both sides by 2, dy by dx equal 4x minus 3 over 2x squared. by differentiating with respect to x. Bring down y. Derivative dy by dx is d2y by dx squared plus bring down dy by dx. Derivative of y is dy by dx, which is mean dy by dx all power 2 equals 4 minus 3x. Moving 3x to the left hand side using the other sign. So y d2y by dx squared plus dy by dx all power 2 plus 3x equals 4, and this is the required. Example number 4. If y equal x power 2 plus 7x minus 1, z equal x power 2 minus 3x plus 15, find d2y by dx squared at x equal 2. From the first one, y equal x squared plus 7x minus 1, so dy by dx equal 2x plus 7. Since z equal x squared minus 3x plus 15, so dz by dx equal 2x minus 3. dy by dz equals dy by dx divided dz by dx, which is mean times dx by dz. It will be 2x plus 7 divided to x minus 3. To get the second derivative by differentiating with respect to z, d by dz for dy by dz, which is mean d by dz for 2x plus 7 over 2x minus 3. It can't be, so I will replace the order of the derivative variables, which is mean d by dx for 2x plus 7 over 2x minus 3 times dx by dz. The derivative of this quotient will be 2x minus 3 squared. Derivative of the numerator is 2 times denominator 2x minus 3 minus derivative of denominator is 2 times numerator 2x plus 7, and after distributing 2 and negative 2 inside both brackets and simplifying, 12 and times the expression dx over dz, which is mean 1 over 2x minus 3, gonna be in the numerator negative 20, in the denominator 2x minus 3 all to the power 3, and putting x equal 2, so the answer will be negative 20 over 2 times 2 minus 3 all to the power 3. It will be negative 20. Number 5. If xy equal 5 sine ax plus 3 cosine ax, prove that d2y by dx squared plus 2 over x times dy by dx plus a squared y equals 0. You have here xy equal 5 sine ax plus 3 cosine ax by differentiating with respect to x. So x dy by dx plus y, and derivative of x is 1, equal 5a cosine ax minus 3a sine ax. Differentiating again with respect to x. So x d2y by dx squared plus 1 times dy by dx plus dy by dx again equals negative 5a squared sine ax minus 3a squared cosine ax. So here x d2y by dx squared plus 2 dy by dx equal, taking negative a squared from the right hand side as common factor, will be 5 sine ax plus 3 cosine ax, and this expression equal x1. So x d2y by dx squared plus 2 dy by dx equal negative a squared xy. Moving negative a squared xy to the left hand side using the other sign, it will be x d2y over dx squared plus 2 dy by dx plus a squared xy equals 0. Dividing both sides by x, it will be d2y by dx squared plus 2 over x dy by dx plus a squared y equals 0. The equations of tangent and normal to a curve. First, the slope of the straight line. The slope of the straight line whose equation ax plus by plus c equals 0 is negative coefficient of x divided coefficient of y, which is mean negative a over b. Slope of the straight line passing through the 2 points x1, y1 and x2, y2 is y2 minus y1 over x2 minus x1. For example, the slope of the straight line passing through the 2 points 2, negative 3, 4 and 1 is 1 minus negative 3 over 4 minus 2, which is mean 2. Slope of the straight line equal tan theta, where theta is the measure of the positive angle that the straight line makes with the positive direction of x-axis. For example, the slope of the straight line which makes an angle of measure 135 with the positive direction of x-axis is tan 135 will be negative 1. If u vector equal a and b, which is a direction vector of a straight line, then the slope of the straight line equals b over a. For example, if 2 and negative 3 is a direction vector of a straight line, then the slope of this straight line is negative 3 over 2. The slope of the straight line is positive if it makes an acute angle with the positive direction of x-axis. And the slope of the straight line is negative if it makes an obtuse angle with the positive direction of x-axis. And the slope of x-axis equals the slope of any horizontal line, which is mean parallel to x-axis, equals 0. The slope of the y-axis equals the slope of any vertical line, which is mean parallel to y-axis, equals 1 over 0, which is mean undefined. The relation between parallel lines and perpendicular lines. If L1 and L2 are two straight lines, then their slopes are m1 and m2 respectively. Then if line 1 parallel to line 2, therefore m1 and equal m2. If line 1 perpendicular to line 2, so m1 times m2 equal negative 1, unless one of them is parallel to one of the x. The equation of the straight line. Number 1, the vector form of the equation of the straight line passed through the point ax1, y1, and the vector u, a and b is the direction vector to it, is vector r equal a plus k vector u, where k belongs to r. The Cartesian equation in terms of the point x1, y1 and the slope m is y minus y1 equal mx minus x1. In terms of the slope m and the intercepted part from y-axis c is y equal mx plus c. In terms of the intercepted parts of x-axis and y-axis is x over a plus y over b equals 1. Remarks. Number 1, the equation of the straight line which passes through L and K and parallel to x-axis is y equal k, and parallel to y-axis is x equal L. The equation of x-axis is y equals 0, equation of y-axis is x equals 0. Equation of the straight line path through the origin point is y equal mx. To get the intersection points of the curve with x-axis, put y equals 0 and find the value of x. To get the intersection points of a curve with y-axis, put x equals 0 and find the value of y. To get the intersection points of two curves, solve the equation simultaneously. Note: the slope of a curve at any point on it is the slope of the tangent to the curve at this point. The normal to the curve is the normal to the tangent, which is mean perpendicular to the tangent as in front of you at the point of contact, which is mean point of tangency. In the opposite figure, the slope of y equal f of x, the curve is y equal f of x at the point x1, y1, which is mean a, which lies on it, is the slope of the straight line CD, which touch the curve at the point a. But the normal to the curve at the same point A is the straight line EF, which is perpendicular to CD. Angle between the straight line and the curve is the angle between the straight line and the tangent to the curve at the point of intersection. Angle between the two curves is the angle between the two tangents to the two curves, and the two curves are said to be intersecting orthogonally if the tangents drawn to the curves at the point of intersection are perpendicular. The slope of the tangent and normal to a curve using the first derivative. The slope of the tangent to a curve of the function y equal f of x at the point ax1, y1, which lies on it, is dy by dx after substituting by the point x1, y1. The slope of the normal to the curve of the function y equal f of x at the point ax1, y1, which lies on it, is negative 1 over dy by dx, which will mean negative 1 over m. The two equations of tangent and normal to a curve is equation of the tangent to the curve at the point x1, y1 is y minus y1 equal mx minus x1. M is the slope of the tangent to the curve, which means the first derivative after substituting by the point x1, y1. Equation of the normal to the curve at the same point x1, y1 is y minus y1 negative 1 over mx minus x1. Example number 1. Find the points on the curve y equal x squared minus 4x plus 3 at which the tangent to the curve, number 1 parallel to x-axis, number 2 parallel to the straight line y minus 2x plus 3 equals 0, Number 3, perpendicular to the straight line 6y minus 3x minus 5 equals 0. Since y equal x squared minus 4x plus 3, therefore the slope of the tangent at any point is dy by dx equal to x minus 4. Since the tangent is parallel to x-axis, so its slope equals 0. So to x minus 4 equals 0, which is mean x equal 2. Substituting by x equal 2 in the equation of the curve, y equal x squared minus 4x plus 3. So y will be 2 power 2 minus 4 times 2 plus 3, it will be negative 1. So the point is 2 and negative 1. Number 2, the slope of the given straight line, negative 2 over 1, it will be 2. So 2x minus 4 equal 2. So x equal 3. Substituting by x equal 3 in the equation of the curve, you get y equals 0. So the point is 3 and 0. Number 3, slope from the straight line is negative 3 over 6 will be half. This is the slope of the straight line. Slope of the normal to it will be negative 2. So 2x minus 4 equal negative 2, which is mean x equal 1. Substituting by x equal 1 in the equation of the curve, so y equals 0. So the point is 1 and 0. Example number 2. Find the equations of tangent and normal to the curve x squared plus y squared minus 4x plus 2y equals 20 at the point negative 1 and 3 which lies on it. Since x squared plus y squared minus 4x plus 2y equals 20, by differentiating with respect to x, 2x plus 2y dy by dx minus 4 plus 2 dy by dx equals 0. Taking dy by dx as common factor, so 2y plus 2 between brackets equal moving negative 4 and 2x to the right hand side using the other sign, it will be 4 minus 2x. So dy by dx equal 4 minus 2x over 2y plus 2. So the slope of this of the tangent at the point negative 1 and 3, it will be 4 minus 2 times negative 1 over 2 times 3 plus 2, it will be 3 and over 4. Equation of the tangent is y minus y1, which is mean y minus 3 equals m 3 over 4, x minus negative 1, which is mean x plus 1. After simplifying this form, you get the equation 4y minus 3x minus 15 equals 0. Using the same method, equation of normal is y minus 3 equal negative 1 over m, which is mean negative 1 over 3 over 4 will be negative 4 over 3x plus 1. After simplifying it, you will find the equation 3y plus 4x minus 5 equals 0. Exercise number 3. Find the equation of the normal to the curve y equal x squared plus 2x minus 3 at each point of intersection number 1 y-axis. The slope of the straight line of the tangent to the curve y equal x squared plus 2x minus 3 is dy by dx equal to x plus 2. To get the intersection point with y-axis, we put x equals 0. So 2 times 0 plus 2. So the slope equal 2. And the point itself, after putting x equals 0, is y equal negative 3. So the point 0 and negative 3, and the slope equal 2. And the slope of the normal is negative half. So the equation of the normal is y plus 3 equals negative 1 over 2 x minus 0, which is mean y x plus 2y plus 6 equals 0. Number 2, the straight line y equal negative 4. After replacing y and right instead of it negative 4 in the equation of the curve, you will have x squared plus 2x minus 3 equal negative 4. Moving negative 4 to the right hand side and simplifying it, you will have x equal negative 1. So the point of intersection is negative 1 and negative 4. Substituting by this point in the first derivative to get the slope of the tangent, it will be 0. Therefore, the slope of the normal at this point is undefined. So the straight line is vertical, which is mean parallel to y-axis and passing through the point negative 1 and negative 4. So its equation is x equal negative 1. To get the intersection point with the straight line, the third one, solve their equation simultaneously. Equation of the curve y equal x squared plus 2x minus 3. Equation of the straight line is y equal x minus 1. Replacing y and writing instead of 8x minus 1, collect the like terms, x squared plus x minus 2 equals 0, factorizing, so x equal 1, and in this case y, which is mean replacing x in the equation of the curve and writing instead of 8 1, will be y equals 0, and the other value of x is negative 2, corresponding value for y is negative 3. So the point of intersection are 1 and 0, negative 2 and negative 3. At the point 1 and 0, the slope of the tangent after substituting in the first derivative will be equal 4. So the slope of the normal is negative 1 over 4. So the equation y minus 0, negative 1 over 4, x minus 1. So the equation is 4y plus x minus 1 equals 0. At the point negative 2 and negative 3, so the slope of the tangent after substituting by this point in the first derivative, so the slope of the tangent is equal negative 2 and of the normal is half. So the equation of the normal is y plus 3 equal half x plus 2, which is mean 2y minus x plus 4 equals 0. Exercise number 4. Find the equations of tangent and normal to the curve y equal 3 plus cosine x minus sec squared x at the point which lies on the curve and its x coordinate is pi over 4. At x equal pi over 4, so y equal 3 plus cosine pi over 4 minus sec squared pi over 4. Pi over 4 here equal 45, so this value of y will be 2. So the point on the curve is pi over 4 and 2. By differentiating with respect to x, so dy by dx equal negative cosec squared x minus 2 sec x, and derivative of sec is sec tan. So it will be negative cosec squared x minus 2 sec squared x tan x. Substituting by x equal pi over 4, it will be negative cosec squared pi over 4 minus 2 tan pi over 4 sec squared pi over 4, it will be negative 6. So slope of the tangent is negative 6 and of the normal will be 1 over 6. Equation of tangent y minus 2 equals negative 6 x minus pi over 4. Simplifying this form, so to have 2y plus 12x plus equals 4 plus 3y, this is equation of tangent. Equation of normal y minus 2 equal 1 over 6 x minus pi over 4. After simplifying it, you will have 24y minus 4x equal 48 minus pi. Number 5. Find the equations of tangent and normal to the curve x equal 5 plus cosine theta and y equal cosine square theta plus root 2 sec theta at theta equal pi over 4. Since x equal 5 plus cosine theta, so dx by d theta equal negative cosec squared theta. Y equal cosine square theta plus root 2 sec theta. So dy by d theta equal negative 2 cosine theta sine theta plus root 2 sec theta tan theta. Dy by dx equal dy by d theta divided dx by d theta, which is mean negative 2 cosine theta sine theta plus root 2 sec theta tan theta over negative cosec square theta. After simplifying it and putting theta equal pi over 4, you will have dy by dx equal negative half. So the slope of the tangent is negative half and of the normal will be 2. So x from here 5 plus cosine pi over 4 will be 6. Y equal cosine squared pi over 4 plus root 2 sec pi over 4 equal 5 over 2. So the point 6 and 5 over 2 lies on the curve, and at this point the equation is y minus 5 over 2 equal negative half x minus 6. This is equation of tangent. It will be at the simplest form, it's y plus x minus 11 equals 0. And equation of the normal, y minus 5 over 2 equal 2x minus 6, which is mean 2y minus 4x plus 19 equals 0. Exercise number 6. Prove that the two curves y equal 2x squared minus 3x plus 8 and y equal x squared minus 3x plus 9 are intersecting orthogonally at point whose x coordinate equals 1. By substituting by x equal 1 in the first curve, so y equals 7, so the point 1 and 7 lies on the first curve. So similarly, in the second curve, by substituting by x equal 1, so the point will be y equals 1 power 2 minus 3 times 1 plus 9 will be y also equals 7. So the point 1 and 7 lies also on the second curve. So 1 and 7 is point of intersection of the two curves. I will get the first derivative dy by dx in the first curve and the second curve. From the first curve will be 4x minus 3, from the second curve 2x minus 3. After substituting by the point 1 and 7 in each one of them, you will have dy by dx in the first one equal 1, in the second will equal negative 1. Their product 1 times negative 1, it will be negative 1. So the two tangents of the two curves at this point 1 and 7 are perpendicular, which is mean intersecting or subtly. Exercise number 7. Prove that the two curves y equal to x squared plus x plus 1 and y equal x squared minus x are tangential, and find the equation of the common tangent at the point of tangency. Y equal to x squared plus x plus 1, we call it number 1. Y equal x squared minus x, so this is equation 2. Solving the two equations simultaneously, you will have 2x squared plus x plus 1 equal x squared minus x, which is mean x squared plus 2x plus 1 equals 0. After factorization, x equal negative 1. By substituting at equation 2, so y equal 2. So the two curves intersect at the point negative 1 and 2. M1 is the slope of the first curve at the point negative 1 and 2, so dy by dx at this point 4x plus 1 will be negative 3. And M2, the slope of the second curve at the same point negative 1 and 2, dy by dx equal to x minus 1 at the point negative 1 and 2 equal negative 3. So the two slopes are equal, so the two curves are tangential at the point negative 1 and 2, and the equation of the common tangent is y minus 2 equal negative 3 x plus 1, which is mean y plus 3x plus 1 equals 0. Example number 8. Find the area of the triangle bounded by x-axis, tangent and normal to the curve x bar 2 plus 3x y plus y squared plus 9 equals 0 at the point a negative 3 and 3, which lies on it. X squared plus 3xy plus y squared plus 9 equals 0. By differentiating with respect to x, it will be 2x plus 3x dy by dx plus 3y plus 2y dy by dx equals 0. So dy by dx, after taking dy by dx as common factor, it will be negative between brackets 2x plus 3y over 3x plus 2y. So dy by dx at the point negative 3 and 3 will be 1. So the slope of the tangent equal 1. Equation of the tangent will be y minus 3 equals 1 x plus 3, which is mean y equal x plus 6. After drawing the curve and tangent and normal to it, to get point B, intersection point of the tangent with x-axis, put y equals 0. I will put y equals 0 in the equation of the tangent. So x equal negative 6, which is mean that the point is negative 6 and 0. The slope of the normal equal negative 1. Its equation is y minus 3 equal negative 1x plus 3, which is mean that y equal negative x. To get the point C, intersection point of the normal and x-axis, put y equal 0. So it will be x equals 0. So C is the origin point 0 and 0. Length of BC is 6 units. So area of the triangle bounded by x-axis and tangent and normal to the curve is half times 6 units, which is mean BC, times the height 3 units. So half times 6 times 3 equals 9 square units. Thank you and see you later.